Hello. Today we're going to take a look at finding conditional probabilities. To start off, if the occurrence of one event affects the probability of the second event, the two events are what? So because one thing affects another, those two events would be dependent. As a percent, what is the probability of getting heads on all three flips of a coin? So that would be flipping it once, getting heads would be 1/2 times 1/2 times 1/2, because those are all independent. So that would be 1/8. And then they want that as a percent, so 1/2 times 1/2 is 25% times 1/2, that would be 12.5%. A bag contains 8 red marbles, 16 white marbles, and 4 black marbles. What is the probability of randomly selecting a white or a black marble? So because you could get one or the other, that would be 20 out of 28, because you can pair those two things together. So 16 and 4, that gives you the 20 out of the total is 28. You could take a 4 out of all those, you get 5 sevens. All right, moving along. Lesson 68. So the probability of two independent events is the product of their individual probabilities. However, finding the probability of two dependent events requires finding a conditional probability. Recall that the probability of B with a /A is a conditional probability. The way that we would read that is probability of B given A. It is read as the probability of B given that A has occurred. Dependent events. So if A and B are dependent events, the probability of A and B is equal to the probability of A times the probability of, that shouldn't just be B, that should be that B given A. Okay, so let's take a look here. Suppose the two spinners shown are spun once. Find the probability that the first spinner lands on a 2, and the sum of the spinners is 6. Okay, so let's say I spin this first spinner, I get a 2. So what's the probability of that happening? That would be 1 out of 4. So the probability, this is the probability of A getting a 2. Now the probability of B given A, so we're looking at the probability that we get a sum of 6 with this happening. So how many options do we have for that second spinner if our first spinner is a 2? So we should know that the only thing that we could spin in order to get a sum of 6 would be that 4. So the probability of that happening, probability of B given A, is also equal to 1/4. So then we take these two probabilities and multiply them together. So we have a 4th times a 4th, and we get 1/16. So the probability of getting a 2 and then having a sum of 6 would be 1/16 in this scenario. Okay, so finding the probability of dependent events. So again, let's take a look here. Suppose the two spinners shown are each spun once. Find the probability that the first spinner lands on an odd number and the sum of the spinner is greater than 4. So here's how we're going to do this one. To start off, let's look at that first spinner. The probability of getting an odd number we know is 1/2. Okay, so if we spin a 1, the only way that we can get more than 4 is by spinning a 4. So the possibilities would be spinning a 1 and a 3, 1 and a 2, 1 and a 1. None of those will be effective for us. If I get a 3, I can get a 4, I can get a 3, I can get a 2, but I can't get a 1. Okay, so anything in blue is greater than 4 and meets that condition. Anything in red is not. So the probability of getting a 4 would be 4 out of the 8 total possibilities that this happens. So because I have 4 things that work down here out of 8, that's also 1/2. So the probability of B given A is also 1/2. So then the probability of both of these things, of A and B happening, would be 1/2 times 1/2, which equals 1/4. Moving right along. The table shows the results of a survey. Let's get out of that. That asked students to state the year and season of their birthday. Find the probability of winter given that it was 1993. So in this scenario, we want to look at 1993. Okay? So the probability of getting winter was 16 out of whatever our total is here. So we got fall and summer, that gives us 20, and then spring and winter gives us 25. So 16 out of 45. 16 out of 45. If you were to simplify that, that's going to give you 35.6%. Now, if we look at it the other way, this can be a little bit confusing for some people, and that's totally okay. But we're looking at what's the probability of having your birthday in 1992, given that it was either spring or summer. So we're interested in it being spring or summer. So all of those numbers there would be our totals. Now the probability of having your birthday in 1992 would be those spring and summer 1992 birthdays. So the case here would be 6 plus 12, which gives us 18 out of, we got 18 plus 20 plus 19. So 39, 49, 57, 18 out of 57. So if you were to simplify those, 18 out of 57 would give us roughly 31.6%. So that's the way that we would do this using a table. So you look at your second number, that given whatever is happening, that's your total amount. That first thing, the probability of something given another, that first part is what your numerator will be, or what you're more interested in. All right. Using a calculator to find conditional probability. A raffle is being held at a school function. A container has the names of 578 juniors and 618 seniors who are participating on slips of paper. Prizes are being given to the first, second, and third names pulled from the container. Once a student wins a prize, his or her name is not returned. What is the probability that the first 2 prizes go to juniors and the third goes to a senior? So first of all, we want to know what our total number is. So 618 and 587. $12.05. So the first thing happening, once the probability first 2 go to juniors, so we have 587 juniors out of 1205. Now when this happens, again, we take that name out and it doesn't go back in. So that's the probability of drawing the first junior. There's your second junior. Notice we lost one number in the juniors. We lost one in the total. Then the last one, we have all of our seniors left, so 618 out of 1203. So what I'm going to do, let's go over to our calculator. I will punch those numbers in. So we got 587 divided by 1205 times, add your parentheses, 586 divided by 1204 times, add your parentheses again, 618 divided by 1203. Okay, so the probability of this happening would be 0.1217, or I guess as far as percents go, 12.2%. Okay, so 12.2%. One more. The mailing center. It was found that on Tuesday, 44 out of 662 envelopes were stamped upside down. On Wednesday, 16 out of 251 envelopes were stamped upside down. And on Thursday, 3 out of 598 envelopes were stamped upside down. Find the probability that that an envelope was stamped on Wednesday, given that it was stamped right side up. So what we are doing in this is we only want to look at the ones that are right side up. So that's our given. So probability of Wednesday, given that it was right side up. So that means our population that we're interested in is only the numbers that are on top. So our Wednesday number is 235 out of, and this will be 618 plus 235 plus 595. So let's, since we got our calculator, might as well utilize it. 235 divided by 618 plus 235 plus 595. Probability of that is 16.2%. Picking that Wednesday envelope if you're looking only at the ones that are right side up. Okay, hope this was beneficial for you guys. If you have any questions, feel free to stop in or watch anything that you might need to again. Find another video if that'd be beneficial for you. I hope you guys have a great day.